Welcome students to the next lecture on the course Analog Circuit. Today we are going to discuss about more insight into the differential amplifier. Myself, Dr. Kirti Vyas from Arya College of Engineering IT. Let's get started with the differential amplifiers. In the last lecture, we have discussed about the DC analysis of the differential amplifier. Now we will take one numerical based on the differential amplifier, its DC analysis, so that the problem can get easier for you to solve. In this particular example, there are certain specifications given for dual input balanced output differential amplifier. We are given with the value of resistance, power supply, and we have to find out the operating point, that is the value of the collector current and value of the voltage across the collector emitter junction, value of VC of the two transistors. Since according to the equation derived from the last lecture, we are already having the value of ICQ given in the form of the voltage drops upon the value of the resistance. The substituting the values given in the numerical, we find that the collector current comes out to be 0.988 milliampere. After this, we find the value of VCE, which is equals to 8.54 volt. Hence, we have derived the value of the collector current and VCE for both of the transistors, as these two transistors are identical. Now, we talk about dual input balanced output type of differential amplifier, which is shown in the figure. As you can see, V1 and V2 are the two inputs applied at the base of the Q1 and Q2 transistors, and the output voltage is measured between the two collectors, C1 for the Q1 transistor and C2 for the Q2 transistor, and they are at the same DC potential because they are biased by same power supplies. Now we move on to the AC analysis. In order to do the AC analysis, all the DC power supply are connected to the ground, and the Q1 and Q2 transistors are replaced by its AC equivalent R parameter circuit. Now to find the voltage gain, we will move forward and apply KVL in the circuits. In this particular circuit, since the two DC emitter currents are equal, therefore the resistances RE1 and RE2 dash are taken equal to RE dash. The voltage across each collector resistance is shown 180 degree out of phase with respect to the input voltages V1 and V2, and this is same as in common emitter configuration. The polarity of the output voltage shown in the figure. Now applying KVL to the two loops, first and second, we find out the value of the two V1 and V2. In order to simplify the calculations, we assume that the value of RS1 upon beta and RS2 upon beta are very small in comparison with RE and RE dash, and therefore we neglect these terms. So it simplifies our equation, and we have two equations, one corresponding to V1 and another one corresponding to V2. Now solving this equation, I1 and I2 are calculated as the first equation the top is about IE1 and second equation is about IE2. The output voltage is given by Vc2 minus Vc1. Substituting the value of currents into these value, we have considered the value of the collector current is almost equal to the value of emitter current. So in place of IC1, IE1 has been substituted, and in place of IC2, IE2 has been substituted. Substituting the values, we find out that the output V0, which is the output of the differential amplifier, comes out to be the equal to the value of the collector resistance RC upon RE into difference of the two inputs applied at Q1 and Q2 transistor respectively, and hence we can say it is appropriate to call this particular DC coupled amplifier as differential amplifier as it is amplifying the difference of the two input signals. Now, the voltage gain of the dual input balanced output differential amplifier can be given as RC upon RE dash. This is our equation 2. Now, we will talk about the input resistance. First of all, we should know what is a differential input resistance. It is defined as the equivalent resistance that would be measured at either input terminal with other terminal grounded. This means that the input resistance Ri1 seen from the input signal source V1 is determined with the signal source V2 set to 0. This has been also expressed in the form of equation below, which is shown below. Here we can have Ri1 is equals to V1 upon Ib1, keeping V0 equals to V2 equals to 0. Similarly, so substituting the value of IE1 into the equation, we find out that Ri1 is equals to twice beta Re dash. Similarly, we may find the value of input impedance for the Q2 transistor, which is also equals to twice beta Re dash, since these two configuration are having the same value of they are having identical transistors. Now about the output resistance. The output resistance is defined as the equivalent resistance that would be measured at the output terminal with respect to the ground. Therefore, the output resistance R01 measured between the collector C1 and ground is equal to that of the collector resistance RC. Similarly, the output resistance RO2, which is measured at C2 terminal of Q2 transistor with respect to ground, is equal to that of the collector resistance RC. So output resistance RO1 is equals to RO2, and they are both equal to resistance value RC. Now, to have more insight into this AC analysis, we take a problem in which specifications are given for the dual input unbalanced output differential amplifier. Here we are given the value of all the resistance, the power supply, and we have to find out the voltage gain, input resistance and the output resistance. Since you can see all the parameters given in the problem are same as the problem which we have already discussed in our earlier lecture, and using the same calculation we may find the value of the operating point, that is the output collector current and potential drop across the CE, which comes out to be IC is equals to 0.988 milliampere and the VCQ comes out to be 8.54 volts. Now, finding the value of Ri1 and Ri2, these are 5.06 kilo ohm and Ro becomes the resistance Rc, which is equals to 2.2 kilo ohm. The voltage gain is equals to Rc upon twice of Re, which is equals to 2.2 kilo ohm upon 2 into Re value, that is 25.3 becomes 43.8. So this is the voltage gain of the amplifier. Now we move on to the next problem. In this problem we have to repeat the example 1 with single input balanced output type of differential amplifier. Since we can say that because the same biasing arrangement and same components are used, which are used in the example 1, so for dual input balanced output configuration also valid for single input balanced output configuration. So the value of IC, VCE, VD, Ri and Ro are like this. Thank you for this particular lecture, attending this particular lecture, and in next lecture we will talk about more of the operational amplifier.